Hello, so I'm going to talk with you all about just some of the course information on Engineering 1. So about me, my name is Mr. Camigo. Degrees, I guess I have bachelor's in physics, bachelor's in math, and a master's in math. I've been teaching math since 2004, and I've been teaching the engineering classes since 2015. So the focus of this class, we have a couple things. We're going to talk about professional conduct. So this is basically how to hold yourself in industry. And we're going to talk about the engineering design process. We're going to talk about project teams and presentation of results. Some of the stuff like project teams due to COVID, we may be just doing a lot of online collaboration, which they're doing that too in the real world. So we're unfortunately not going to be able to do a lot of the hands-on together working on a breadboard project or Arduino or something like that at this point due to COVID. But we will still talk through the design process, project teams, and presentation of results. We may be creating reports and posters and some e-flyers and documents that way, videos rather than like an oral presentation in the class possibly. Again, due to COVID-19. So it's going to look a little different this year than previous years. So COVID-19, we're going to require mask needs to be covering both nose and mouth. You need to wear it at all times when you're in class. We're going to have no food in the class. And you're going to have a seating chart. You need to stay seated where you're assigned. We want to minimize the amount you're moving around in the room. So wherever you're assigned, you stay in that area and try to keep yourself socially distant from the people as much as possible. And I'll be setting up the seating chart in a way to try to maximize distances between people. So class environment, I want you all to treat each other with respect. Expect everyone to follow the student code of conduct. We need to keep this a scent-free zone, so don't apply cologne or perfume in the classroom. Careful with the computers. Don't break them. Don't take them apart. Don't yank wires out of them. Just we need them to stay good and nice, so please treat them nicely. You're going to have 3 restroom passes for 9 weeks. Save that for emergencies. If you do use a restroom, make sure you're staying on the first floor and you're not wandering around the building. And if you're going to leave the class, you need to make sure that you get a pass to be able to leave the class. So if you go on with engineering, kind of looked at a bunch of colleges, and green is, these are courses that turned up in most colleges as required. Yellow are classes that some colleges required, some other ones didn't. And this orange one here is for computer engineering that gets required sometimes. So college algebra is kind of the equivalent of algebra 2. And then pre-cal, so most colleges require you take college algebra, pre-cal, cal 1, cal 2, cal 3, differential equations, and then also over here take linear algebra. Depending on how your placement tests in college go, you may start out at pre-cal or start out at cal 1 and be able to skip over some of these. Yellow classes, partial differential equations, vector calculus, probability statistics, those get required sometimes. And if you're going to go into computer engineering, they might want you to take discrete mathematics. If you want to be engineering technician or a technologist, the math requirements are a little bit less. Most of them want you to take up to cal 2. Some want you to take cal 3 and diffie-q, linear algebra, probability, and statistics. Some of them want you to take those yellow courses, but most want you to take up to cal 2, it looks like. We're going to focus a lot on the engineering design process. This is the one we used last year at Stanford's engineering design process: empathize, define, ideate, prototype, and test. Again, empathize is where you get to know the people that you're going to design the product or process for. Define is where you build a point of view statement that kind of frames what the problem is. Ideate is where you generate ideas on how to solve your statement. So whatever problem you framed in the define statement, your point of view statement here in the define step, ideate will be generating ideas to solve that. Then once you have your ideas, you start building prototypes, and then you test and compare the prototypes to each other. And depending on how testing goes, you maybe go back and refine prototypes and then retest and refine and retest. If none of the prototypes work, then you go back to ideate. or go back to the define step and work your way back up to prototype and testing until you get something that works the way you want it to. We're going to be saving stuff, and they got rid of the student drives, so all the students have a Google Drive. So you guys are going to be saving your files to Google Drive. So make sure that probably want to come up with some sort of file structure there to keep your files organized. So use your folders, subfolders, maybe come up with a naming convention, and you may want to make an archives folder for old stuff that you're not using anymore. But you do probably want to make sure you're keeping your Google Drive manageable. So would be a good idea to look at doing something with your file structure there. You'll need either a notebook to keep as engineering journal. These composition notebooks are great. You guys can get the spiral notebook also if you want, or anything like that. That should be fine for what we're doing this year. This is where you record some of your initial planning in the prototyping phase, or sorry, in the when we develop a thing through the engineering design process. This is where you'll do your initial empathize, define, ideate stages, some sketches and stuff. We'll do some math equations in them, things like that. For an e-portfolio, I encourage y'all to start one. Here's a couple of the common platforms there, but there's other ones out there. Make sure that you're only putting your best work in there, and make sure that you put all steps of the design process of your work. I'll show you some examples a little later in the course. And below this video, there's going to be some other video, some more information that I want you all to check out. And then to finish up, I want to kind of jump on over to Canvas and talk to you guys about that a little bit. Oh yeah, we're going to be doing working in a project group. So this is, we're going to talk through the steps of doing that. A big one though is pull your own weight. So if you're part of those project groups, when we get around to doing them, part of your grade is going to be based on I'm going to make everyone tell me what they're doing, and part of your grade is going to be based on how well you execute that. So if you don't do your part of the project, that's gonna show on you rather than your teammates. But yeah, if you're working in a project group, plan before you get going, make a schedule, complete what you need to. Make a positive working atmosphere. Don't be hard to work with. Make sure you're pulling your weight, meet your deadlines, document what you're doing. Think about how to resolve stuff that could pop up, and record stuff in your engineering journal as you need to. For time management in this class, we're going to be given lots of design challenges, and need to make sure you're using your time wisely and effectively. So as we go through and do these problems, we want to make sure that you're using your time effectively, you're creating project schedules, and then sticking to it. If something goes wrong, maybe someone's absent, or y'all's schedule got behind, you need to update it. It's a good idea to do proof of concept stuff before you commit. So that's like before we decide we're going to do this, let's make sure that this thing actually, maybe if it's something using a motor, let's make sure the motor turns the way we think it does before we commit to using it. And again, make sure we're meeting deadlines. So software, hardware, we're going to use SolidWorks a lot and Python a lot. LabVIEW, we'll use some in this class. And then Arduino, Raspberry Pi, and breadboards. Due to COVID-19, we can't use shared stuff, so I don't know that we're going to get around to using that this semester. Hopefully everything clears up and we can use it, but until then, we're going to be sticking mainly to the software side, mainly SolidWorks and Python for this year. We'll do a little bit with LabVIEW, but let's see. I think that's it there. So I did want to jump over to the course. Let's see. And so if you go to a course, let's say that we go to our engineering design course. It'll drop you off here. All the information's in the modules tab. So if you go down to where it says modules, click on that. That'll get you here to where all our stuff is. And like we're in the intro to course tab right now. But let's click on this. So if you click here, this will carry you through to me talking through a little bit of stuff. It'll pop up. Well, maybe we'll pop up the slides. If it doesn't pop the slide up, you can click on this and it'll download it, and you should be able to open it from there. So this got some quick little slides there, and then after that you got a practice quiz. So the way you're going to navigate this course is you click the modules tab. That takes you to where all the course information is, and it goes from top to bottom. If you ever get lost in the course, just click modules. That'll take you back. And then what we're going to do is some of these things have, like, there's some little writing samples that are going to happen, and there's some stuff that we're going to do with Python. And a lot of these things that are going to get turned in, you will turn them in at the bottom of each module. So like the end of week 1, this has where you turn the assignments for week 1 in, and there is a little week 1 quiz that needs to be taken down there. So what I've tried to do, the way I've designed the course, is as you complete your work, you turn it all in down here at the bottom of the week. So like for week 2, as we get these assignments done, we turn them in down here at the week 2 assignments turn in, and that makes it real clear what's been turned in and what's not. So if we click on one of these just to kind of see what it looks like, and can preview it. So, you know, here's where we turn in the assignment for engineer, technician, technologist. You'll upload your file there. Reflection of our engineering design process, upload the file here. Python file for Python user input. You'll just upload the file there. And that's basically, instead of having kind of these things all mixed together, kind of, this is gonna keep stuff a little bit cleaner. And then again, if you get lost, click on the modules tab and it'll pull you back through here. All these little attendance checks, these are just you just, you know, make sure you get in there and click on them for each day so that you get credit for being there for the day. And that's basically, I think that's a good overview. So we'll stop here, and then there is a little bit of more information in a second video.